for B, you guys should have already found your zeros, because you're just setting the numerator equal to 0, right? Okay, and when you factor, hopefully we just recognize right away this was the difference of two squares. Okay, so the zeros, you're just going to take the numerator, x minus 2, set it equal to 0, x equals 2, and then we're going to write that as a point so we can graph it. Alright, and then for the vertical asymptote, that's where you're going to take the denominator, and I would take it in its factored form, because then you know right away, right, if you set this equal to 0, set x minus 1 equal to 0, you'll get x equals negative 1, x equals 1. Okay, remember to have the x equals with those, because those are lines. And then the last thing is the horizontal asymptote. When you do that one, just look at the degrees. Okay, so the degree of the numerator is what? Yeah, because the degree of the numerator is 1. Degree of the denominator, highest exponent, is 2. So for the horizontal asymptote, you have 1 is less than 2, or the numerator degree is less than the denominator. And if you go up to your chart, when you have the numerator is less than the denominator, what is your horizontal asymptote? Y equals 0. Alright, now you do have 3 asymptotes that you want to put on your graph, okay? So let's go ahead and put those in. So you have the x equals negative 1, which is one of your vertical asymptotes. So you have 3, yes, combined. And then you have 1 here. And really what these all do is they sort these into sections, and you're going to have to find points in each section. Okay, and then y equals 0. And we only have one x-intercept, so we're definitely going to need our table here. So our x-intercept is right here, 2, 0. Now, it's okay that it's on the horizontal asymptote. When you are graphing, you never cross a vertical asymptote, but you can cross a horizontal asymptote. That does happen. Alright, and then again, when you go to graph this, you have to put parentheses on this one around the top and the bottom. And use the x squared minus 1. That way you don't have to do a double parenthesis. Okay? If you just put in the factored form and you didn't put an extra set of parentheses, you not get the same thing. You guys ready to see this graph? You already did it? So there's 3 parts to it. So 1, 2, and then this one is going to continue. It's just right above the line. And so with this calculator, your pixels can't see it. If you guys have a flat one, aren't the colors cool? You can see the color right above the line. Okay? All right, so let's plot some things using our table. So I'm going to go to my table, and the first thing I want to do is I want to know what's happening on the left side of this asymptote here. So I need to go to my negative values. So negative 5 is at negative 0.3, negative 4 is at negative 0.4, so negative 4, negative 0.4, I can graph that. Negative 3 is pretty close to that, so I'm going to go to negative 2, which is at negative 1.3. Negative 1 and a third. Okay, and we know that this is looping down, okay, but you could also go back and you could do the halves. Okay, and then like here you see 0, 2, so you could plot that point while you're there, that's fine. I like to do mine in the branches, like I told you. But anytime you wanna see what's happening in between, just go ahead and say, okay, if this is 1, this is negative 1.5. I want to know what's happening there. So at negative 1.5, you're at negative 2.8. So you're almost to 3. So if you want that so that you can create your curve, you know where it's going, that's fine. Remember, this will not cross the vertical asymptote. So you have one of your branches. Now if you look at the next set, so you have 0, 2, but at negative half, you're at 123.33, and at this half, you're at 2, which means somewhere in between there, you have to dip down. So it's going to look like that. So this is not a perfect parabola in here. This one's kind of slanted a little bit. And then I am going to go back and, so I just plotted negative 1/2, the 3.33, and then the negative half 2. And then you're also using this to help you. So you can see that it is going to be a curve here. And you can see what's happening here, right? It's going to be following this. So let's investigate with our table. All right, so I'm going to start at 1, and I'm going to go to my table. So at 3, I'm at 1.25. Look how small these are. So what is happening past 3? These are just like these are right above it. They're like so close to it. And then this would be at 2, I'm at 0. At 1, I'm at an error. So, oh, did I plot that wrong? I did. Yeah. This should be 2, 0. This is going to be right above it. It's going to be right above it. And then, so what I want to do is find out what happens in between. I'm going to show you another way you can find that. Ready? You can go to your graph, press second, and then the trace button. It says value. So if I want to know what happens at 1.5, I can just press enter. It'll tell you, oh, when x is 1.5, y is negative 0.4. So at 1.5, I'm about right there. So what's happening is this is very, very small. This is right above the line. And then this is going to be following this asymptote straight down. And that's how you can create your other branch. No. Okay, and then the last one, we'll definitely get to how to find your asymptotes and see what their graph looks like. So you have 4x minus 12 over x minus 1. So I told you the first thing you always want to do is factor. So when you take out that GCF on the top, you're going to take out that 4. And then when you find your zeros and you set the numerator equal to 0, okay, sometimes this number out front can cause a little bit of confusion. If there was an x with it, you would have something to solve for, so be careful. That's why I like to set it equal to 0, because if it has an x, I would solve, but there's nothing to solve for, so that's not going to give me anything. The only 0 I have for this is 3. So 3, 0 is my x-intercept. For the vertical asymptote, you have x minus 1 equals 0, so x equals 1. And then this is the one where for horizontal, the degrees are equal because they're both what? Yes, degrees are equal to 1. Okay, so then what you do is you put the leading coefficient over the leading coefficient. What's the leading coefficient in the numerator? 4. What's the leading coefficient in the denominator? 1. What's 4 divided by 1? 4. So then this is just y equals 4. Sometimes it could be a fraction. That would be fine. Sometimes you have to simplify it. That would be fine. But now you have your two lines. You have x equals 1. And you have 1, 2, 3, 4, y equals 4. think actually we'll do this graph tomorrow. But if I kept it like that, most of the graph is up here. So based on what I gave you, let's look at the graph. Because we're going to have to make that go by 4s, okay? But I do want to show you what it looks like. So 4x minus 12 divided by x minus 1. Again, I have those parentheses there. And see how this looks? Oh, okay. And see how that looks really close to what we have been graphing?
So we have to just scale it differently and put the one?
Yeah, so, yeah, to put it on there. Or else when you go over here,
well, we need to get a highlighter.
because you see how you look at your points. See how this is at 5, 5, 6, 8, 12. Yeah, so we'll fix that tomorrow. Okay? And if you guys need graph paper, I have some.